solid waste collection and transportation. Container systems.
Hauled container systems. Containers are transported to disposal or processing sites and then returned or replaced. There are a few types to consider. Roll-off containers are large containers that can be loaded onto a truck. Then we have front and rear load containers, which are smaller containers that can be lifted and emptied into collection trucks. The advantages? Well, they're suitable for large waste generators and bulky waste, and they're flexible for different types of waste. But there are disadvantages too. Higher transportation costs due to the movement of containers, and they require specialized trucks.
Stationary container systems. In this system, containers remain at the collection point, and only the waste is transported. There are different types. For instance, curbside bins, which are small bins used for residential waste. Then, we have dumpsters, which are larger containers for commercial or multifamily residential buildings. The advantages include lower transportation costs and efficiency for frequent collection schedules. However, there are disadvantages. It requires regular maintenance and cleaning, and there's limited capacity for large waste generators.
Layout of collection routes.
Route planning principles. Efficiency. Minimize the travel distance and time for collection vehicles. Coverage. Ensure all areas are serviced without overlap or missed locations. Safety. Avoid hazardous routes and ensure safe operations for workers and the public.
Types of collection routes. Grid route follows a systematic pattern such as rows and columns. Suitable for areas with a regular street layout. Circular route vehicles travel in loops returning to the starting point, effective for areas with irregular street patterns. Sweep route collection vehicles follow main roads, sweeping through side streets, commonly used in suburban areas.
Optimization techniques play a crucial role in efficient waste collection. Let's dive into a few key methods. First, route sequencing. This involves determining the optimal order for stops to minimize travel distance and time. It's like solving a puzzle where every piece must fit perfectly. Next, the use of Geographic Information Systems or GIS. These systems help in planning and optimizing routes based on spatial data, providing a clear visual representation of the area. And of course, load balancing. This ensures an even distribution of workload among collection vehicles, preventing any one vehicle from being overburdened.
Now, let's talk about transfer stations and transportation. These are critical components in the waste management process, ensuring that collected waste is efficiently moved to its final destination.
Transfer stations. These facilities temporarily store and consolidate waste before it's transported to disposal or processing sites. They play a critical role in waste management. Waste consolidation combines waste from multiple collection vehicles into larger transport units, making the process more efficient. Waste sorting involves separating recyclables and hazardous materials from general waste, ensuring proper disposal and recycling. Compaction reduces the volume of waste, which helps in lowering transportation costs significantly. Design considerations. When designing transfer stations, several factors must be taken into account. Location is crucial. Transfer stations should be strategically placed to minimize travel distances for collection vehicles, reducing overall transportation costs. Capacity must be adequate to handle the volume of waste generated in the service area, ensuring smooth operations. Environmental controls are essential. Measures should be implemented to prevent issues like odor, leachate, and pests, maintaining a safe and clean environment.
Transportation. Efficient transportation is key to effective waste management. Compactor trucks are used to reduce the volume of waste, allowing for more efficient transportation. Long-haul trucks are essential for transporting waste over long distances to disposal sites. Scheduling is vital. Coordinating transportation schedules ensures timely waste removal and reduces downtime. Route optimization is another important aspect. Planning efficient routes for transport vehicles minimizes travel time and fuel consumption. Load management ensures that vehicles are loaded to their maximum capacity, making transportation cost-effective.
Effective collection and transportation of solid waste involve careful planning, efficient route layout, and strategic use of container systems and transfer stations. By optimizing these processes, waste management operations can be more cost-effective, environmentally friendly, and responsive to community needs.